Hello, my name is Jinhoon from Sogang University. I'm advised by Professor Youngjae Kim. Today's announcement is SGX-SSD, a policy-based versioning SSD with Intel SGX. Attacks of ring 0 level rootkit malwares are extremely dangerous. The ransomware enhances the privilege of victim and compromises the software-based backup system. It finds and destroys victim local and remote backup data. To solve this problem, versioning SSDs such as BBSSD and Project Almanac were introduced. Instead of implementing the backup system at the host end, the backup system is implemented in SSD firmware. SSD firmware provides a completely isolated space from the host. Therefore, even if malware compromises the victim's server such as OS, the backup data is secured from them. Versioning SSD preserves all files for a fixed retention time. However, space overhead in SSD extremely increases as all files are backed up regardless of the importance of the files. To free up space, versioning SSD aggressively erases old backup data in a way that limits retention time. However, the integrity vulnerability occurs when malware's dwell time is longer than the versioning SSD's retention time. Here, dwell time means the period that the malware stays undetected in the victim system. Let me give you an example. Suppose that there are important file secure.txt and unimportant file temp.txt created on March 3rd. The versioning SSD has a retention time of 30 days, and the malware's dwell time is 7 days. In March 4th, ransomware encrypts 2 files and ransomware is hidden undetected. From this point, the previous version of the files are preserved for 3 days. On March 7th, the previous version is deleted because retention time has passed. On March 11th, malware is detected, then user requests recovery to versioning SSD. However, the recovery fails because the previous version is already deleted. The real problem is that malware's average dwell time is longer than the retention time of versioning SSDs. Figure shows the statistical distribution of malware's dwell time. Project Almanac is state-of-the-art of versioning SSD, which provides longest retention time among them. Project Almanac provides 3 to 56 days of retention time, depending on the workload write intensity. However, more than 50% of malware has a dwell time of 60 days or more. Therefore, existing versioning SSD is vulnerable from at least 50% of malware's attack. To solve the existing problem, we propose SGX-SSD. SGX-SSD is a policy-based per-file versioning SSD. Each file version is maintained according to the policy set by user. We define 3 types of policy user can set: retention time, number of version, backup cycle. Number of version is the maximum version to keep. The backup cycle refers to the cycle of storing files. In this way, SGX-SSD minimizes the space consumption for version to keep deeper history for important files. SGX-SSD guarantees integrity from malware with long dwell time. Let me give you an example. Suppose that secure.txt and temp.txt were created in March 3rd. The user set a retention time of 30 days for secure.txt and 0 days for temp.txt. Dwell time is 7 days as before. When malware invades system on March 4th, only secure.txt previous version is preserved for 30 days. On March 11th, malware is detected, then the user requests recovery to versioning SSD. Here, recovery successes because the previous version of the secure.txt is safely preserved. SGX-SSD has the following design challenges. First challenge is that users' requests inevitably pass through the untrusted OS. The request can be tampered with by a man-in-the-middle attack. How can we guarantee that the policy request entered by the user is safely delivered to the SSD? Second challenge is that SSD is a block device, so there is no file semantic, whereas policies are assigned on a file-by-file basis. In order for the SSD to perform policy-based versioning at the block level, how can the SSD recognize the file semantics corresponding to each block? In summary, we define the integrity vulnerability of the existing versioning SSD. To solve this, we propose a per-file versioning implementation in SSD firmware. By solving the aforementioned two challenges, the integrity of the file can be selectively guaranteed even if the OS is compromised. The detail of SGX-SSD can be found and archived. Thank you very much.